two disjoint measurable sets is measurable. The proof. Let E1 and E2 be two disjoint measurable sets. Now we want to show that E1 union E2. We want to show that this is also measurable. Since E1 is measurable, by definition, for any set T, we say that the measure of that T is equal to measure of T intersection E1 plus measure of T again intersection the complement of that E1. Let's call this one equation 1. Since E2 is also measurable, for any T star, now I call this one T star, we say that the measure of T star is equal to measure of T star intersection E2 plus measure of T star intersection the complement of E2. Let's call this one equation 2. Let T star be equals to this. That is T intersection E1 complement. So then I want to replace T star with this in equation 2. So I have measure of, instead of T star, I'll write this T intersection E1 complement equals to measure of, instead of T star, I'll write this T intersection E1 complement intersection E2 plus measure of, instead of T star, I'll write this T intersection E1 complement intersection E2 complement. I call this 3. So now I want to put this 3 in 1 because this and this are the same. So now I have one is measure of T equals to measure of T intersection E1 plus, instead of this, I'll write the whole of this, measure of T intersection E1 complement intersection E2 plus measure of T intersection E1 complement intersection E2 complement. By Lebesgue's law, we have the measure of T equals to the measure of T intersection E1 plus measure of T intersection E1 complement intersection E2 plus measure of T intersection E1 union E2 complement by Lebesgue's law. Then we have the measure of T to be equals to the measure of T intersection E1 union T intersection E1 complement intersection E2 plus the measure of T intersection E1 union E2 complements. Using the knowledge of set theorem, you can say that this is equals to the measure of T intersection E1 union E1 complement intersection E2 plus the measure of T intersection E1 union E2 complement. Since E1 and E2 are disjoint sets, let this one be E1 and this one, this is E2. So from this, we can, it's obvious, it's so clear that E1 is a subset of E2 complement and E2 is a subset of E1 complement. So this now can be written as the measure of T equals to the measure of T intersection E1 union E2. Since this one is inside this, so the intersection is this, plus the measure of T intersection E1 union E2 complement. So from this now, we can conclude that for any T, the measure of this is equal to the measure of this intersection this plus the measure of this intersection the one they complement. Hence, U E1 union what E2 is also measurable. Thank you.